manager here at LogicGear, and he's going to outline the methods and test specialists that were involved in the different stages that allowed the development team for Test Architect to accomplish their goal of automating tests during a 2-week sprint cycle. So with that, I will turn the session over to Subu.
Thank you very much for that introduction, Joe. Hi, everyone. Thanks for taking the time amidst your busy schedules to attend this webinar. We are really excited to present this webinar because this is something that we have done over the last year, and we have really got some good results out of this approach of automation within the Agile sprints. And we have time tested this approach, and now we would like to share it with the testing community out there. So let's get into the discussion. So in today's webinar, we will see how obviously how we achieve automation in the development sprint. We will talk about the software testing within the Agile landscape. We will briefly touch upon the Agile setup and the various processes involved. In order to understand how we got to the point where we are able to achieve test automation within the same sprint, I first have to give you a background of our struggle to automate the tests and the challenges associated with them. As we will see, the struggle was caused by not just one or two factors, but many. So at one point, we had to step back and look at it as a holistic problem and not just as an automated testing problem. Now this I will elaborate when I talk about LogicGear's approach to testing and automation in particular. So to go into further discussions, I need to set the tone of this webinar itself. We leveraged Test Architect to automate our software, and our software, again, being Test Architect Enterprise, that is a commercial software that is available for automated testing. Now, this is more like a battle between Test Architect and Test Architect. Makes sense, right? So we create Test Architect and we use Test Architect to automate it. Now, as many of you would have worked in an Agile process, this is the process that we followed, and I'm sure a lot of people do follow this process widely. So in our Agile setup, we still do have a product owner, and the product backlog, and the product owner was directly working with our CTO and our customers to make sure that what new features go into Test Architect and put those into the product backlog. And we had a sprint planning meeting, and this sprint planning meeting was where the product owner comes together with the team. The team comprised of the test software architect, the software developers, the test architects, the test developers, and the project manager. The project manager being the Scrum Master in this case. So we initially used to have a 3-week sprint, and we narrowed it down to 2-week sprint to accommodate automated testing and to find the right balance, which we'll be talking in detail later during the webinar. So now looking at the role of testers in an Agile setup, the testers are given equal importance in an Agile setup. Usually in a waterfall model, this is not the case, where the testers come in only during a test planning, which takes very down the line. But automated testers in an Agile process are hidden behind the cloak of the test team. Very few teams we have found have separate automated test teams or designated automation engineers within the team. Well, we never had automated test teams separately. We always used to have the automated engineers within the, I'm sorry, there's a problem with my screen. So we always have automated engineers within the test team, so which was more because that we thought that the automated testing was an extension of the manual testing, which proved to be a catastrophic case for us, because automated testing should be seen as equally important as manual testing. So the test architect product development team followed the Agile processes that encompasses all the above players The team built the product in Agile and was performing manual testing on new features and had been building the regression test suite. The automated tests were delayed at release after release despite adding more resources to keep up with the pace of the product development team. So the team figured out as the issues that were stopping them from achieving successful automation were they were trying to convert manual tests to automated tests. While there's nothing wrong with that, the team went through, the main reason being the team went through releases testing new features using manual tests. The regression tests kept piling up. The team had no choice but to automate the manual tests at that point. While this approach served the purpose at some level, but the coverage was less than 50%, which means that we had to employ more resources to do more manual testing even during the regression testing phase. So the team regularly faced maintenance issues and was not able to scale the tests when the product underwent changes. Now, piling up the regression suite made the automation lag by at least a sprint. As I mentioned briefly before, the team scraped through to automate manual tests, and despite that, the team was barely scratching the surface. The team used action-based testing methodology to automate. They were missing the point. They were not looking at the bigger picture. They were not taking a holistic approach. The volume of manual tests and frequent releases didn't allow them to test using a different approach. Now what happened? This created a huge backlog. The regression pile grew. The team had to push the lower priority features as backlogs. The automation process was pushed to a lower priority, and it was treated as a separate entity as the team felt that the lower priority features could be pushed. Simply by not taking a holistic approach, we were just piling our backlogs of features that had to be automated. Now, frequent changes to user stories. We all have heard this story, and in Agile, it's a flexibility that is offered to product owners to create better products. But this is actually a nightmare for automation test engineers because the flexibility is actually changing the user story amidst a release will throw all the scripts that we have out of whack, and we will not be able to reuse of the scripting that we have done, and we've all seen that. So this in turn again piled up to the backlog that we have created using the manual test for the regression test suite. Now the team's dependency on programmers is not a new situation for an automated test team. So features that use niche technologies that are not supported by any software out of the box, any automated test software out of the box, need the help of programmers to create, custom controls or custom functions that can be leveraged within the automated test tool. And this is not new with Test Architect too. Though Test Architect supports a wide range of technologies, we still have our own battles in terms of creating custom actions using programming languages like Python, Java, or C#, and bring these custom actions back into the Test Architect to do our testing. Now what happens when we are dependent on programmers are, the programmers are very few in numbers in an automated test team, and if any higher priority development work comes up, these programmers are moved to higher priority development work, which makes automated testing again lag. So the bottom line is the automated testing got the least priority in the Test Architect Agile software cycle, which made testing the quality of the product in a questionable state. So what attributed to this struggle? This can be categorized into 3 different challenges that we faced. One is the technical challenges, and I've spoken in depth about automating manual tests. So automating manual tests is a big technical challenge because when teams start automation, and if they don't start it with the first version of the product, what they do is the first approach would be to go after the manual tests that are created and build a framework around it. Now that could prove to be a technical challenge because the scalability and maintainability issues creep up when the manual tests change or when the flow of the application changes. And the second problem that we face is waiting for the UI to be ready. Now in an Agile sprint and with a 2-week the UI is usually ready for testing around the 2nd week. Now if the automated testing waits till that point to automate the UI, then there will be a lot of issues that will creep up because the UI is not stable as soon as it is given to the testers. So automating that would not serve the purpose. So the automated test team runs into different challenges, and if they don't get enough support from the development team, the test team would just skip a couple of lower priority features, and it is going to affect the coverage. The third technical challenge that we faced was actually a combination of the third and fourth point. It's mainly the bottom-up approach to automating tests. What it means is, again, it goes back to the same point of automating the manual tests and building automated tests using a lot of scripting. Now, this would work in a small application, but for an enterprise-wide scale test architect kind of an application, this approach did not serve us better. What happened was we were automating the tests. Automating the tests meaning we were following the flow of the application, so which means that when something breaks, we have to change the tests, we have to change the actions, everything has to be changed, which is again a nightmare. And porting over tests to different platforms was not an option using this approach. The second challenge that we faced was people. So we had lack of resources, and the available resources did not have enough time to do their job. They were pressed to get the product out, so they had to test the key features, and there were customizations within the product for specific customers that we had to perform. So all these took priority over people concentrating on coming up with an automation test strategy. Now this attributed the lack of resources and lack of time attributed to improper planning and estimation. When people, press and work more during a particular sprint, they were using the same kind of analysis to do the sprint planning for the next Agile process. So this led to improper estimation, and the testing, the manual testing itself started to lag, which meant that the automated testing again took a back. The last problem was communication between the teams. What I mean is, in an Agile sprint, to achieve successful automation, the team should be in sync. The developers and the testers should collaborate the way the developers and product owners collaborate to develop the software. Automated testing was not considered as a separate as a software development problem. It was considered as something nice to have. So the developers did not take much priority to help resolve the automation problems that the testers had. The third important challenge that we faced was the organizational challenges. In order to make the product better and in order to get the product out in time, the organization had to prioritize what was important. And at this stage, obviously, the automated tests were not considered, because that was, again, considered to be something as a nice-to-have feature. And with a return on investment mindset that the company had for the product itself, we put more resources into creating more manual tests. We did not take the time to step back and see what is good for the quality team in terms of automated testing. So the overall picture is that the team, the people, the technology, and the organization put together could not find what is the right balance to achieve automated testing. So right around this time last year, we took a step back and we wanted to evaluate where we were going wrong in terms of automated testing. So that's when we thought about implementing ABT, which is action-based testing. And let me explain what action-based testing is. Action-based testing uses the advanced keyword method for which covers test management, test development, and automation, with a large focus on the core of test design. And this test design is the main driver for the success of automation. And the central product in action-based testing is a test module, which we'll be looking at in the subsequent slides. So this action-based testing process gives testers the power to be on par with developers. Now, our CTO, Hans Buwalda, he designed this concept of action-based testing, and in order to implement this process, it had to be a discipline that had to be imbibed within the team, and it had to be driven down from the top. Now let's dive a little deep into what action-based testing is and how it looks in terms of implementing it. So within Test Architect, again, Test Architect is a product that is built around the action-based testing concept. So within Test Architect, we made test design as the key, and we use other concepts which are similar to other products, like mapping the interfaces, and we use as the term suggests, it's action-based testing, so we have an action library within Test Architect that can be leveraged to create tests that can be created at a business level. Now these actions can be separated into system level actions that are lower level and generic, such as click or select, or application level actions. These are higher level business actions that can be created using a combination of multiple actions or can be created directly from the application. Intermediate actions are a combination of mid-level actions that serves very little purpose in terms of at a middle layer in between the application and system level actions. And at last are the custom actions that gives the power to programmers to create their own custom program using C#, Python, or Java and include it within the action library. Now this is a pictorial view of action-based testing. We have designed action-based testing like the chapters in the book, and the test cases are part of the test modules, and they are typically the result of test development. Now the test, as I said earlier, the test design is the key, and we have two levels of test design within the action-based testing. One is the high-level test design, that's the test development plan, and that also gives an entry into creating test modules and test objectives. And then there are the lower level test design that are creating test cases, creating actions, and automating those actions. Now, big differences that we found while creating this change was, the difference between the test design and test automation. So as I said earlier, the struggle that we had was people were looking at it from a bottom-up approach and converting manual tests, etc. But from an action-based testing perspective, we look at test design, looks at the bigger picture. It gives a top-down approach, and it aggregates test modules with common objectives. Now the common objectives can be directly correlated with the user stories, which means that there's a good traceability between the test modules and the user stories that we create. And we were also able to separate the business level objectives to UI level validations, which means that if you want to test business level objectives across multiple platforms, it is always, we thought, was better to separate them from the UI level validations, which are specific to a particular browser or a particular platform. By making this, we just had to change the actions that were targeting a particular change in an application, and we did not have to go about making the changes in all the tests. Now, how does test automation fit into this whole process? Now, test automation in a traditional sense, according to what we did before, was capturing all the interfaces, getting all the action libraries, and creating the tests based on the manual tests that we had. But at this point, we were following the test design approach, is where the design was done at a high-level stage, and then the test automation process itself involved interface mapping that could be done both manually, working with the developers, and also can be done if the UI is ready for a particular feature. And creating the action libraries, and as I explained these individual action levels, we have different levels that can be created using combination of actions within Test Architect, or can be created using the application itself. Now the test execution itself involves running the test against the application, which is common to all test automation process, and generating the results report. Now before we move into breaking down the process itself, I would like to take some time to explain what an action is. So an action is a meaningful task performed within the application. It can be a low-level task such as a click or select, as you see, that are called system-level action. In Test Architect world, is a click. What it means is the low-level action performs the same way in any application built using any technology. An intermediary action can be a combination of a click and select. Now this action can be renamed, or it can be a custom name as a myClick. Now, if you want to use both these options together to do a click and a select at the same time, you combine these two actions and became an intermediary action, and that can be used to design tests. Now, this action will perform both the click and the select on the application under test with the indicated parameters. Now, consider an application with a checkout button. This checkout button can be included in the test architect library as an action. Now, we can go about by doing this in two ways. The first way would be to use a system level action and make a combination of the system level action with different actions in the application and form the checkout action. For example, by using the same action click on 3 different places, you can do click on a product, click OK, and click checkout to create the checkout option. Now when you create this checkout action this way, this action can be used and tests to perform all of the 3 above tasks of clicking on a product, clicking OK, and clicking on the checkout button. Now, once you have created this action, this can be termed as a user-defined or an application-level actions, and this can be used in unison with other actions, the system-level action, to create a much higher-level business-level action called as an enter order. Now, enter order takes in parameters from click, select, checkout, and when all these parameters are entered, the order can be created. Now, this enter order can be the same action that can be used on if you're testing on web, or if you're testing on a mobile product, or if you're testing on a desktop application. Now, this is what an action means in the test architect. So it's time to look at how we reorganized our team structure in order to accommodate the change that we were making within our automated test team. In our Agile team structure, we had the product owner who created the product backlog. Now we brought the test module definition to as equivalent as creating the product backlog. Now, the test modules and the test objectives within test architect, as I said, directly correlate with the product backlog. Now, having it along with selecting user stories from the product backlog made sense to us. So we made test module definition as the first step in creating test development. So within test module definition, we have the test development that are creating user stories, creating documentation, understanding all these things are really essential inputs that go into test module definition. Once the test modules are created, it went through a rigorous acceptance criteria. It went to product owners for questions. It also talked about the situations and relations between different aspects of the test, application under test. Now, the test modules can be broken down into the main level test modules, the interaction test modules or the UI level test modules, and the crossover test modules are a combination of the business and the UI level test modules. Within Logic Year's test automation, the product development team, the manual testers and the business analysts were involved in the test development phase, but this can be extrapolated into other real-world scenarios where software managers, subject matter experts, business analysts, and product owners can also be involved in the process of test development. Now, at the time of the sprint, the test modules that are defined and the test objectives that are defined are further expanded into test cases, interface definition, action automation, and test execution. Now, all these happen over a 2-week period during the sprint. Now, what we do first and what we do last is what we're going to see in the process breakdown later. At the end of the sprint, what we see is the product is developed, the tests are ready, and the automation tests are ready. Now let's break down the process. We need to show you how we incorporated this theory into practice. Now, after fiddling around with the sprint duration, initially we were in the 3-week sprints. This didn't work well for the number of stories the team was developing in that sprint. The estimation and the story point calculations created a lot of problems. That's when the team hit the sweet spot by switching to a 2 sprint. At this stage, I would like to make a point that a sprint cycle is totally based on a team's need. As no two teams are alike, the same way, the sprint cycle also need not be similar. It depends on a lot of factors such as estimations, number of features available, availability of resource, and expertise of resources, etc. Now, during the first week of the sprint, we did the user story selection. Now, the user stories were selected based on a story point calculation, which is an historical analysis that is done during the sprint planning meeting. The Agile software development team collaboratively selected the stories that can be accomplished within the same sprint. The team also takes into consideration backlogs from the previous sprint while planning for the current one. The team assigns story points, which is calculated through historic analysis for the selected stories. This also takes into account integration with other platforms, the number of platforms to be covered, etc. Now, we also made sure that at this point we introduced a twist to this whole story by saying that you have to take in automation into consideration when you're doing a story selection. So which means that you are done only when the automation is done. And this is a big mindset change, and it had to be driven down from the top. So our CTO took it up on his own wing, and he made this change, and he drove this process down into the product development team. So what we decided was any story point or any feature that cannot accommodate automation during that sprint will be pushed as a backlog to the next sprint. This does not mean that we would be neglecting user stories and the product development itself is going to suffer. This had to be done, and we had to bite the bullet to make automation a priority, because we realized that once we start doing the process, once we make the upfront investment, we will be able to realize the benefits later. Now, during the week 1, once the story points are decided, the test team goes into a high-level test design process. Now, they are included in part in discussions with the product owner. They also do work items like user stories and acceptance criteria are well understood, and the product owner has to sign off on every little understanding the test team has. Now, the test modules that have to be developed later have to be identified. Now, these test modules should have a clear and concise test objective, and these test objectives have to correlate with the business objective of the user stories. Once the test modules and the test objectives are identified, these are baselined, and once it is signed off by the stakeholders. At this stage, the stakeholders are the product owners and the software architect. The reason we include the software architect is because the team will be working closely with the developers at a later stage in order to create interface mapping and actions even before the UI was made ready for them. Now, the test modules that are, that correlate with the test objectives forms the base, forms the heart of the whole process, and from this point, it is just a trickle-down effect. During the week 2, we create the interaction test, or we can also call it as a low-level test design. Now, this is the stage where we drill down into each of the test module, and we look at each of the test module and come up with test cases. Now, at this point, we also look at the existing actions that are in the action library, both the system level, the intermediary level, and the application level actions that we have already created during the previous releases. We take all those into account to see what are the things that can be reused. And then we also sit with the developers to see what are all the various features that are coming in the UI, and what are all going to be their properties, because the developers at this point are almost ready to hand over the UI, which means that They are all set for what are the properties that are going to go into each of these UI level field. For example, what is the property that's going to go into a particular button, or what is the property that we're going to use in a particular web page? All these details are gathered by the testers in order to create the interface map and in order to create the actions. Now the test design process is completed using the logical flow created during the high-level design. And even at this stage, every little thing is approved by the various stakeholders, as I said before. Now the tests that can be implemented just using the existing actions are created much faster. And this is the stage where we include the automation engineers. Now, who are those automation engineers in Logic Gear's product development team? Automation engineers are the ones who help the test design team to capture the properties within the UI or work with the developers to fill in the actions, to create the actions manually. Why we do that is the actions that if the actions and the interface mappings can be created manually, this will save a lot of time, and this will not make the team wait for the UI. And when everything is created manually and when the team runs the test, it can be validated against the UI at that point. And that is the basic idea of using the automation engineers at this point. Now the major stakeholder for the interaction tests are the automation engineers, who will be looking at the logical flow, the high-level design, the low-level design, the test cases that are created, the action placeholders that are created for the new test, and they would be giving an approval saying that this can be accomplished manually and this has to wait for the UI. Once that sign-off is approved, we go into the next of automation and execution. And this is the stage where the new actions are created. The new actions are created, as I said, or either by manually or through using the UI. And the major change that we did was to create the interface mappings manually and not by using any spy tool or any interface viewer within Test Architect application. The reason being is, the first thing, this can be done upfront without the UI. This can save a lot of time, and this can also give a technical understanding of what's going into the product itself. Now, how we do it is we do it collaboratively with the developers. So when the developers do their low-level design of creating a web page or creating a particular feature in the application, we sit with them and we take an interface map and we look at what are all the different properties that needs to be identified, and we talk to the developers who will be able to give us the various properties that goes into a particular window or a particular page. Now we use those properties and create all those interface mappings manually. And all the new higher level actions that have to be created, will also be created manually, because again, it's the same concept. We sit with the developers and we get all the properties that they use for a particular button, particular field, take those properties, and we build the action manually using manually. Then actions that were just placeholders during the design stage are automated once the application is delivered. There will be some actions in every application for which the properties, even though the properties are available, they may not be directly used on the application. So at this stage, we decide what are the custom actions that we are going to use, what are the custom implementations that we may have to do. So we decide on the programming language that best suits for future scalability or maintainability, and that is the stage where we use the custom actions. Now, during the sprint, the week 2, the application is delivered and the automated tests are parallelly created. Now at this stage, these are nothing but manual tests. These are nothing but manual actions that have no life. All the actions, all the interface mappings that have been created are just placeholders. They're not validated against the application. But this is the crucial stage where once the UI is ready, we are going to run the tests against the application. At this stage, there could be a lot of failures, and we did see a lot of failures, and we still do, because the developer who gives the properties for a window or for an object or for an action could have changed the property, or the design could have changed, and there could have been no time to let us know. So this is the time we take to sit and fix all these different issues and make sure that, and by repetitive iteration, all these tests can be fixed against the application. Now, this may look as if this takes more time, but if you consider it, the automated tests for a sprint planning will probably take an hour or two, depending on the number of features and the complexity of the features and the complexity of the tests. So spending that hour or two to keep iteratively do it will probably, the automated team spends a day maximum to fix all the issues, having created everything manually. Now once all these issues are created, all the tests that have been written can be tested automatically for the next 2 or 3 days that are remaining in the sprint. Now this gives the testers the time to do some exploratory testing, some random testing on the application, while the automated test takes care of all the functionalities and all the features that are going out in that sprint. Now this not only gives us the power of testing the application both at an intuitive level and both at a functional level, this also gives us time or reduces the time to update regression test suite or maintain regression test suite, which in itself is a separate task for most teams. Now by doing this, we cut down our regression testing time, because the automated tests, once they are iteratively run across the application and all the issues are fixed, the automated tests can be directly used to update the regression suite, and the regression test can start running parallelly against the application itself. So now, looking as a recap, looking at the 2-week sprint, the week 1, we select the stories that can be accomplished end-to-end from development to automation. We assign story points and estimate the number of stories that can be completed, and this also includes automation into the picture. Now, the next is creating placeholder for the new actions and the interface mapping, and identify the historical actions that can be reused, create high-level test design, create the test modules and objectives, and review test modules, objectives, and flow with the automation engineer and the team, and obtain the final sign-off before we move on to the lower level design. During the week 2, we create the low-level design, we create the test cases, we create the interaction cases, we implement actions as and when either the application is ready or we do it manually with the developer. We execute the test cases and we report the bugs, and the actions are updated based on the changes, based on the bugs that we create, based on the changes the developers make, the actions are updated, and we keep repeating the 2 steps until the automation is completed for all the selected stories. Now, what did we achieve by doing this? We were able to automate all the functional tests within the current release. We were able to test the functional tests in an automated fashion and create automatic regression suites where necessary, and we were also update existing actions, and we will also be able to reuse existing actions for any new tests that had to be created. And this is how we successfully achieved automation within the same sprint. We'd be glad to take.
All right. Thank you, Subu. That was really a great presentation. We do have a couple of questions, so let me read the first one to you. It's if we don't use manual tests in the base, how do we manage the test case to execute between manual and automation?
So as I explained before, the automated testing itself is a part of the manual and automated tests. So if you looked at the process breakdown that I mentioned, we designed the tests, we designed the actions, we designed the interface. All these designs are manual, were done manually, and we automate only the actions, which means that the tests are still manual tests, such as click on the checkout button or enter order, all these are manual tests. So by creating manual tests in an action-based testing format, all these tests can be created using actions rather than writing tests by the traditional format. By automating the actions, you are not only doing automating all the functional stories, you also have time to do exploratory testing.
Okay. Let's see. Another question is, your regression tests are automated, so there's no manual maintenance in the tests?
No, we are. I wouldn't say that we are 100% there, but this exercise is actually helping us to get to no zero maintenance. But of course, there are functionalities that are one-off customizations that we do for specific customers. Even though we do regression testing on that customizations, those don't need those don't warrant automated tests, and we tend to avoid automated tests when we have to write custom programming for any specific niche functionalities that we develop using niche technologies. So at those stages, we still do manual regression. We don't try to automate every piece there.
Okay. Let's see. We got a few more coming in. What if the UI is completely new and the test team does not know the name of the controls?
So this is a process change that has to happen within the test or within the product development team, and it has to be top down. It has to come from the product owner or business stakeholder, and the collaborative effort between the developer and the test team will obviously prove very tough at first, and there will be a lot of finger pointing, blame games, but at the end it's a very rewarding experience, because once you set the tone and once you go through the painful process for the first two sprints, you are definitely going to get in a groove and you're going to be working more collaboratively, which is the whole point of doing an agile cycle.
Then another one, is the high-level test design defined, or the test module defined outside of the sprint, for instance, in the backlog grooming?
Well, that's a good question. The high-level test design is actually not outside of the sprint, but identification of the user stories and the test modules is definitely is done during the sprint planning and the product backlog meeting. The reason being is the test module itself and the test objectives associated with each test module directly correlate with the user stories or the user functionalities, which makes it easier to define the test modules during the product backlog meeting. And defining the test modules and the test objectives at that stage and getting a sign-off will definitely go a long way in creating a better lower level design and creating better maintainable and scalable tests.
Okay, and we have a question here. They want to know, how was the process accepted by the development team? Did we see any drop in velocity of the group? It was actually a collective decision. We did not see a drop in the velocity of the development group per se, but we did see that the number of stories that we included did change initially. But as I said, the power of action-based testing comes into play when you have the action library built. So what is, when we did this change at the first time, we had to pick a limited number of stories to make sure that we are getting the right flow and we are getting the right speed. So in order to do that, we had to start from scratch, which means that we had to be conservative and go for a limited number of features for that sprint where we first started, and then we had to get the development team to work with the QA team. But once we did the process and once we started building the action library at that stage, we were able to leverage into a lot of existing actions, and the developers were more involved because they knew that they were making a change that made the product that they developed come out with a much better quality. All right. Well, thank you, Subu, and I think that's all the questions we're going to be able to answer during this session. We thank you for them. The ones we didn't get to, we will address those in an email that we get out to everyone. We'll address your questions individually. The recording will be sent out to everyone. This will probably come out in a day or two, and we'll make it available to you. So we thank you for your attendance, and we hope you have a great rest of your day. Thank you.